All right, Mr. Splendor, the floor is yours, sir.
All right. Can you guys hear me?
Yes, we can.
All right. Um, my name is Splendor. And I am a data analyst and a business intelligence analyst. And I'm here to talk about database design, basically. All right. Actually, there's nothing much to to actually talk about. I just want us to like go straight into what we have to like do today. Uh, I think we are short on time, so I need to like hit the ground running. Okay. So I don't know. The camera is not working. I don't know. I think the moderator disabled it. I, I think some of you would want to put a face to the name or something like that, but that's all right as well. It's okay. So,
Mr. Splendor, I can just allow your video so they can
oh, okay.
so they can see if that's what you want.
Okay, no problem, please.
All right, so yeah, we can switch it on now.
Okay. All right. Please let me know if you can see me. Can you? All right.
Yes, yes,
Okay.
we
So
can.
yeah, that's me. Hello, everybody. Nice to be here. Nice to have you guys here. I think would be discussing one of the most important part of SQL today. So sit tight with me. Okay. So yeah, I think I'll take my video back so that I'll not distract you guys. Okay, so I will quickly share my screen and then we get things moving. Okay. So let me share my screen. I don't have the privilege to share my screen as well. Mr. Moderator, can you hear me? All right, thank you. So yeah, I think someone has a question. Ajala, do you have a question for me? You're raising your hands. Yes,
Ajala,
you
you can
could.
talk now. I've given you the mic. Ajala, maybe you just go on. I guess maybe it's a mistake or so.
All right. Okay. So we're gonna kick things off as soon as possible. Now, like I said before, this is one of the most important part of SQL. And honestly, I'm really sorry. I've honestly been so busy. I really, I really don't know how much justice has been done to other topics or how it was introduced, um, so that I'd know like the how I'm going to go with you guys. But nevertheless, I think I'd start a little bit from the basic level of things, assuming that you guys have actually not learned anything. Okay, good. So, have you guys, has anybody done installation of Microsoft SQL Server?
Yes, they all have, most of them.
Okay. They've all done installation of Microsoft SQL Server. Okay, that is good. That is good. Thank you so much. All right. So now, basically, majorly, what we're going to be talking about today is databases. Okay. And now, the main reason why we have SQL and the main reason why we talk about SQL is because we have databases, and because there are things called databases. Okay. Now, I think one of the first questions that you might want to ask me is, what is a database? Okay. Now, in layman terms, we could say that a database is a structured collection. It is a structured collection of data that is organized in a way to easily access manage, and update information. Okay. And basically, it serves as a centralized repository for storing and retrieving data, allowing for efficient data management and retrieval. Okay, good. That is basically what a database is in layman's terms. Okay, so basically we could say that a database is a structured collection of data that is organized in a way to easily access, manage, and update information. Okay. Now, say for example, your Microsoft Excel can be said to be a database. Okay, your Microsoft Excel can be said to be database, but it is not a database uh, in the real sense. Okay, I mean, as a matter of fact, I think different companies makes use of Microsoft Excel. They store their data inside of Excel, so a database is kind of like somewhere where you like store your data and have all of that stuff. Now let me take you guys a little bit back. Okay, now let me break everything down, because I think I want to do big justice to this, because I think uh, for me, I think the um, databases, understanding databases is the foundation of understanding data. Okay, whatever part you want to pivot into, whether be it data analysis, be it data science, be it data engineer, any part you want to go into, I think understanding databases is actually one of the most critical things involved. Okay, now, as a matter of fact, there was a survey that went on, I think last year or so. You understand? So I think what happened was that they scraped all the job, or they collected all the job that had data in the description, all jobs that had things to do with data analyst, data science, data engineer, and all of that. They scraped all of those jobs from the internet, from LinkedIn, from all of those job websites. Okay, I think one thing that stood out was that over 65% of all the jobs that had data to do with it required the knowledge of SQL. And there will be no SQL if there was no database. Now, like I said before, let me take you guys a little bit back. Okay. Now, in the past, humans stored data using file sharing systems and all of that stuff. Okay. But now, one thing was very, very important. Okay. Data grew very, very exponentially. Okay. I think we call it in big data, we call it the 3 V's, okay? And the 3 V's are basically velocity, and I think something like veracity and volume, okay? So data grew both in volume, in the velocity, and I think in the veracity, something like that. I've forgotten that second one. I think it's veracity, okay? Now, because of this exponential growth of data, there was a need to have a system that could be used to store this large amount of data that humans produce, or that businesses generate, and all of that stuff. Okay, that is where databases came in, or where they come in. Okay, now let me explain. Let me put into perspective for you. Now, in perspective, the amount of data that humans have generated from 2003 up till today that I'm speaking to you is greater than the amount of data that the world has produced, or the world has seen, from 2003 going back to the start of the world. That is how data has grown. From 2003 up to today, the data is larger than what we've seen from 2003 going back to when the world started. That is to tell you how large this data is. Okay, every second, every minute, every hour, data is constantly being generated. That I'm talking to you right now, I am generating data. That transaction, your bank transaction, the money you are sending, the money you are receiving, that is a data point. Okay, that text message you are sending, that is a data point. That tweet you are liking, that Facebook post you are commenting on, that is a data point. You see, data continually grew. And you see, these companies, one thing is very, very sure. One thing we know is that companies and businesses that knows how to use data, or that knows how to properly, who understands their data, these are the companies that are the top. And because of this, companies are now striving to like get hold of this data so that they'll be able to make better decisions. They'll be able to improve their businesses, increase their profit, and even automate their processes and all of that stuff. Okay, so you see, because of the benefits that data provides to a business, companies, they want to have a piece of this. Okay, companies generate millions and billions and trillions of data. So because of this, there is a need to have a system that can properly house this data, that can properly hold this data together. And that is where a database come in. Okay, that is basically where a database come in. Okay, now majorly in the broad sense of things. Okay, now there are two types of databases, majorly in the broad sense. Okay, I think if we break it down a little bit, we might have other ones, but in the broad sense, we have SQL databases, two types of databases, which are SQL databases, which is also called relational databases. And then we have another type of database called NoSQL databases. Okay, these ones are not relational databases. Okay, so now since we are looking at SQL, and since we are talking about SQL, basically let me talk about SQL a little bit. What is SQL? SQL is the standard language that is used for accessing and manipulating databases. Okay, you see the way I am interacting with you using English language. Say, for example, you are the human, and say, for example, I am the database. You see the way you interact with me that allows you to understand me, or that allows you to be able to easily access me. Whatever means of communication you use, that is what we could say, or that is what we could liken SQL to be. So it is basically the language that is used to communicate with databases. And there's something I want you to understand. I tell my students, SQL is divided into two parts. Okay, we have the syntax part, and then we have the logic part. I think the logic is where most people find it hard. Actually, SQL, in my opinion, is the easiest programming language, or if not the easiest programming language in the world. You understand? Because the syntax, what is syntax? Syntax is basically the rules that governs how you write a language or how you speak a language, or the rules that governs it. Okay, so the syntax is basically easy because the syntax of SQL is based on the principles of English language. So if you understand English language, definitely you would understand SQL. You understand? Good. So, like I said, SQL is basically the language that is used to communicate with databases. And we are talking about SQL because they are databases, okay? So we want to learn about database design and optimization today, okay? Sorry, okay? So now I said we have two types of databases. We have the SQL databases, and then we have the NoSQL databases, okay? NoSQL databases, meaning that they don't use SQL, okay? Good. Now we are going to focus on the main one, which are relational databases, or sometimes some people also say relational database management system. Okay, relational database management system. Okay, now what are relational databases? Now, in layman terms, we say that relational databases relational databases are types of databases that stores and manages data in tables with predefined relationships between them. Okay, do you guys understand this? Are you guys following me? Am I going too fast? Do I need to slow down a little bit? Am I okay? All right. All right. Okay. So let's continue. So like I was saying, relational databases, they are a type of database, or they are types of databases that stores data in tables. Okay, they store data in tables. What is a table? Your normal Excel sheet like this is a table. Okay, good. So now there are different types of relational databases. Okay, and an example of it is Microsoft SQL Server. This one we are using. You see this application we are using. This is called SQL Server Management Studio, or some people also call it SQL Server. This is an example of a relational database management system. You have MySQL, you have your Oracle, you have your Postgre, all of that. Those databases, they work on the principle of relational databases. Okay, so now let me further break down, go into what relational databases are. Like we said, relational databases are types of databases that stores and manages data in tables with predefined relationships between them. Okay, and each table inside of a relational database, okay, consists each table that is inside of a relational database consists of rows. Okay, the rows that describe entities, and a set of columns that holds the attributes. Okay, the attributes of an entity. Okay, let me quickly show you what I'm talking about. Okay, good. Now you see, when you open your SQL server, when you connect your database, when you come to your databases here, I mean, I already have a database. Okay, so I have a database here. As you can see, this database is called BankDB. Okay, This database is called Bank DB. So this database is a database that contains data for a bank and all of that stuff. Okay, so if I click on it to open it, then now you could see this is a relational database. Okay, normal, this is a relational database. And as you can see, this relational database, the data that is stored inside of this relational database is stored inside of a table. Okay, so if I open the tables up, you'd see it. Okay, good. So you can see I have different tables here. Okay, you could see I have the accounts table that is talking about the accounts of the bank, the accounts they've been opening, and the accounts that they have in their records. We have the ATMs, we have the billers, we have the branches, we have credit cards, we have customers. All of these tables are holding separate information that they are supposed to hold. Okay, say for example, if I open the customers table, okay, say for example, I open the customers table. Now, this is the customers table. This is a typical table that is inside of a relational database, okay? Like I said, a table is made up of rows and column, okay? So this is a column, okay? This is a customer ID column. This is a first name column. This is a last name column. This is a date of birth column. This is the address, phone number, and email. And then this is a row, okay? So the rows of a table, they store the actual value, okay? It stores the entity, what, yes, that is basically what it is. So you have row number one. So for row number one, the entity is customer ID number one that has a first name called Adewale, that has a last name of Adeola, that was born in 1985, May the 15th, and has an address of 123 Lagos Street, Lagos, and then has a phone number and has an email. Good. That is basically what this is. Are you guys following? Are you with me? All right. Good. Okay. So now the next thing we are going to look at, see how I am following this stuff logically, okay, step by step. Okay, I am following this. First of all, we talked about databases. Okay, we broke down what a database was. Then we looked at the types of database. We said there are two major types. We looked at relational and NoSQL. Our focus is on relational database, so we stepped into relational databases, and then we said that relational databases, they store and manage data in tables. Good. So now what we are going to look at is tables. Sorry. We're going to look at tables. Okay. So the question is going to be, what are tables? Okay. Like I said before, relational databases store data about entities in tables. Okay. And these tables are defined by columns and rows. Okay. They are defined by columns and rows. Okay. Now, the rows represent the values or the entities. Okay. So the rows represent the values or entities. We call it entities. Okay. Or we have the columns that basically talks about or that defines the attributes of the table. Okay, good. Now we are going to look at, okay, let me also explain something. Now, in relational databases, tables are also called relations. Okay, tables are also called relations. Okay, now, good. So inside all of this now, we are going to look at the characteristics of a table, okay? We're going to look at the characteristics of a table. Now, the first characteristic that we've looked at is that a table has rows and column, okay? Where the rows in the table contain the actual data or records, okay? And each row represents a unique instance of the entity that that particular table is designed to model, okay? So for example, in a customer table that we have like this, each row represents a unique customer, a different customer. So as you can see, each row represents a unique instance of the entity that the table is designed to model, okay? And then we also have columns, okay? Another characteristics of table are columns, okay? And these columns in a table, they define the attributes or properties of the data, okay? Now, and each column has a specific data type, which we are going to look at. We're going to look at all of this, okay? So such as text, number, date, or all of that stuff. I'm going to come to this, okay? Good. And then another thing you should understand is another characteristics of tables is that tables typically have a primary key, okay? What we call primary keys, okay? And a primary key inside of a table is a column or a combination of columns that uniquely identifies each record in the table, okay? So the primary key column is a column, or the primary key inside of a table is a column or combination of columns that uniquely identifies each record that is inside of the table, okay? Good. Let me ask a question now. Let me ask a question. Now, is there anybody here? Okay, good. As a matter of fact, I think most of us here are youth corpers, okay? So I think you have your service number. True or false? True or false? You have your service number. You have your service number, yeah? Good. Now, do you share your service number? Have you seen anybody that has any two person that has the same service number? Any two person that has a service number, the same service number? Good. That is basically what primary keys are, okay? Now, the main job of the primary key inside of a table is, again, I will say it again, to uniquely identify each record inside of a table. That is basically what the primary key does, okay? Uniquely identifies each record inside of a table. So inside of this table that is called customers, ladies and gentlemen, who can tell me what is the primary key column inside of this table that is called customers? This table that I'm looking at here. Perfect. Perfect. It is the customer ID. You see this customer ID uniquely identifies each customer here. No two customers can have the same ID. Okay, no two customer can have the same ID. See, everybody has their own separate ID. Good. That is basically what the primary key is, and that is basically what it does. Okay, good. So we are going to look at another characteristics. Okay, now we are going to look at another characteristics of a table, which is the foreign key. Okay, good. Now in relational databases, relationships between tables are established using foreign keys. Good. Okay. And a foreign key in one table, refers to the primary key in another table. Sorry, I don't know what is wrong with my hands. Okay, creating a link between the two tables. No problem. I would explain. Okay, I will explain. Good. So what do we mean? Okay, someone is asking if the phone number can be used as a foreign key. While the phone number is unique, I don't think it is logical for the phone number to be used as a primary key. It is not logical at all. And like I told you, SQL is made up of syntax and logic. So in SQL, that logic does not go at all. Good. So now, foreign keys, okay? Now, let me show you another table. Now, let me even talk about the reason why we have foreign keys, okay? The reason why we have foreign key is because of one characteristics of tables that tables have that is called normalization. Okay? These characteristics, the reason why we have foreign keys is because of one of the characteristics that table has that is called normalization. Okay. Now, the question is, what is normalization? Okay. Now, normalization is basically the process where tables are broken down. You understand? Okay. Where tables are broken down to reduce redundancy and to improve the integrity of the data. Okay. Good. Let me just explain this for you because SQL is very, very logical. Okay. Good. Now, let me tell you something. There's something you should understand. You see inside of this bank database that I have, you see that the different tables inside of this bank database, you see, I have account tables. Okay. If I open the account tables now, you would see that what is inside of the account table is just basically information on the account that the company, that the bank is opening. Okay. So you see, we have account ID, we have the account type, we have the balance in the person's account, we have the interest rate that the bank is charging for that particular account, and then we have the created date. That is the date that that account was created. Okay. Good. So if you come to ATMs, same thing. If you come to billers, it is same thing. If you come to branches, now, inside of SQL and in relational databases, related information is stored inside of one table. Related information is stored inside of one table. And the concept that brings about this, breaking down tables, okay? Now, normally, you are expecting that since we are talking about a bank, we would have all of the information inside of one big table. So inside of one big table, you come and see accounts and you come and see, but it is very bad because data that is inside of that big table will become redundant. And also, in a, say for example, say in a bank now, where high level of privacy may be needed, you will be able to have privacy on some type of data. So anybody that comes will just come and see any data. Anybody that comes will just look at any data. So because of all of these things, databases need to be, tables inside of a relational database, they need to be broken down, okay, into separate tables, okay. Related information needs to stay in one place. You understand? So that is why anything that has to do with accounts, we have it in a table that is called account. Anything that has to do with ATMs, we have it in a table that has to do with ATMs. Anything that has to do with customers, you see, we have a table called customers. Anything that has to do with credit cards, we have it separate. Okay, good. Now, because we have these tables separate, the issue arises when we want to retrieve information that is inside of, maybe, let's say, for example, you see, I have customers table here and I have account table. You see, these two tables are different. Okay. What if there comes a time when me as a data analyst or as an analyst, you want to retrieve information or you want to do an analysis that cuts across more than one table? If you want to do an analysis that cuts across one or more table, it means that you need to join those two tables together to be able to query the data. And that is where the foreign keys and the primary keys, that is where they come in. That is why we say in relational databases, the relationship that exists between tables. Remember, tables inside of a relational database, they are called relations, okay? The relationship between tables are established using foreign keys, okay? And the foreign key in one table refers to the primary key in another table, creating a link between the two tables, okay? Let me explain this. Let me explain. The foreign key in one table refers to the primary key in another table. Let me show you, okay? Good. So what is the name of this table? This table that I'm looking at now, what is the name of this table? This table that where my screen is right now, what is the name of that table? What is the name of this table where I'm looking at? The table you are looking at right now? Anybody? Anybody? Anybody help out? Good. This is the customers table. Okay? This is the customers table. Now, notice inside of the customers table, remember, you people agreed before that the primary key of the customers table is the customer ID. We all agreed. Good. Now, let's come to this table. Okay? Now, you see this table? This table is the account table. Okay? This table is the account table. Who can tell me what is the customer ID? What is this column? What is it doing here? What is the customer ID doing inside of the account table? Good. Inside of the account table, the customer ID as a column is a foreign key. Do you know why it is foreign? It does not, normally, it does not belong, the key does not belong to this table. This is the table, this is the key that belongs to this table. It is the account ID. That is the primary key of the account table, okay? So if you see a customer ID table that is coming from a customer's table, you know customer ID here is a primary key here. So if you see it inside of the account table, you know that it is a foreign key, creating a link between the customer's table and the account table. Now, this stuff I want to do might be a little bit advanced for you guys. I don't know. Have you guys done joins? Did you guys do joins? Did you guys do joins? You guys have not done joins. Hey, we. All right. Okay. Now, joins might be a little bit complex or might be a little bit advanced for your level, but trust me to break it down in the simplest way possible. Now, okay, let's say, for example, we are going to be assuming the position of a data analyst in a bank. We are going to assume the position of a data analyst in a bank, okay? Now, you are your own sitting down as an analyst or as a data analyst in the office, and then your manager comes up to you and says, how far? Esther, please, you know you are the analyst now. You know we don't know all these things. Please, we want you to help us to retrieve the account. Okay, they want you to help us retrieve the customer name, the customer first name, and their last name with the account type of the customer and the account balance of the customer. We want you to, now, mind you, you see, the two information is stored, the information that is needed is stored in two different tables. Mind you, they are saying customer first name and customer last name. The customer first name and customer last name is inside of the customer's table. And then anything about account is inside of the account table. They say account type and balance. You say, okay, I am the analyst. Trust me to give you your thing sharp, sharp. Do you guys understand the case scenario, the scenario that I want to use? Are you understanding the scenario? If you don't understand, please let me know. I would adjust it a little bit. Okay, so we understand the case scenario. Good. So now you now jump on your computer as the analyst and you have access to the data. Okay, good. So you start to write a query. Good. Now I tell my students, if you want to write joins in SQL, there's something called the order of execution. You need to think the way that SQL thinks. And in order of execution, the way we write SQL code is not the way that SQL interprets the code. In the order of execution, if you write your code now, say for example, if you say select, if you say select from where group by, if your SQL code is like this, who can give me, who can tell me where do you think SQL, what do you think is the first line that SQL is going to read inside of this code? Like, say okay, say, okay, let me say for example, select from account.
Um, Mr. Splendor, if you're still connected, we can't hear you anymore. Let's just give him a few minutes. I guess his network tripped off or so, but I'm sure he'll come back. So you guys should just hang tight. You guys can hear me now? Hello. Okay, okay.
Hello, ladies and gentlemen. Can you hear me?
Yes, boss.
Oh, sorry. um, I'm using Starlink, okay, for my network, and I don't have a UPS, so if the light trips anytime, my network goes off. That's why. So I think they just tripped the light a little bit, and then it just went off. I'm sorry. Okay, I'm back. All right. So I was writing a query that I wanted to use to explain to you guys something. Okay. So I just wanted to explain order of execution to you guys. Okay. So now, as you can see, we say select account type, the balance from the account where account type is equal to checking. Okay. So let me just remove this one. Okay. So if I execute this code now, this would be the result of the code. Oh, wow.
We can't see your screen.
I'm sorry. Wow. Sorry about that. How about now? Can you see?
It's yes, yes. Nice.
Eh. Eh, All right. Are we on the same page? Can you guys see my screen? All right. Good. So if we write this code and we execute this code, this is the result it threw back to us. Okay. So we selected the account type and the balance from the accounts table where the account type is equal to checking. Okay, so it has returned the balance and the account type. Now, let me ask you, what line of code do you think SQL read first when he wanted to run this code for you? What line do you think he ran first? Oh, wow. You guys said select. No, that's not select. It's not select. Okay. The first place SQL read from was the from. Okay. Because first of all, SQL needs to know the table. Okay. It needs to know the table where you are retrieving the data from, which is this. This is the table. Eh? Then what is the next line? What is the next line? What do you think is the next line is going to read? The next line. Okay. Now, the next line would be the where, and then the last line would be the select. Okay. So, as an assignment, I want you guys to read order of execution in SQL. Order of execution. To properly understand SQL, you need to know how it thinks. And it is the order of execution that will tell you properly how SQL think, how it executes this code, what it checks for, and the thought process. Okay, good. So let me go back to our scenario. Good. Remember, in the scenario I gave to you guys before, in our scenario, basically what I was talking about, I said that your manager comes to the office and gives you a task. Okay, say we have a customers table and we have an account table. Okay, so go. So your manager says, from get me the first name and the last name of all our customers. Okay, and then their account type and their balance. Okay, so the type of accounts they have and then their balance. Perfect. Okay, so you know what to do. Now you know that these two information that is sorry, the information that is asked of you is stored in two different tables. Okay, we have the customers table and we have the account table. So to do that, we need to write joins in SQL. I normally tell my students to start with the from, like I showed you here in the order of execution. This is where SQL is reading from. Okay, so you start from that place so that it goes easy for you. Okay, good. So any table that stays in the from in the join is the first table. So in this scenario, what is our first table? What is the first table? Where the first information we are retrieving, we are getting from, or between the customers table and the accounts table, which of this table has the primary key that is now the foreign key from what I showed you guys before? Which of the table has the primary key that is creating the link between the customers table and the account table? Good. From this, you can see that it is the customers table. Okay, you can see that it is the customers table that has the customer ID, and it is still the customers table that has the customer ID that is creating a link between these two tables. So here you say customers. Okay, good. This is customers. I think it is in plural. Yeah, yes, it is customers. Okay, so now I'm going to say join to the customers table. This is where my second table comes in. What is my second table? We are doing this together. What is my second table? The second table is the table that is called account. Okay, good. So we say account. Okay, good. So now we are almost done with the join. Oh, it is now remaining one thing. Okay, the next question that SQL will ask you is, where is this join happening? Or what is creating the relationship between these two tables? And mind you, it is the primary key and the foreign key that is creating the relationship. So we are going to give SQL where this relationship is happening, okay? Because SQL needs to see where these two tables, where they have something in common. Okay, now a join is just like marriage between a man and a woman. Before a man and a woman they get married, they must have things in similarities, and that is basically what SQL is looking for. Okay, so now we need to say on where. What is the table with the primary key? The table with the primary key is what? Table with the primary key is what? So we say customer dot, what is the primary key? What is the primary key in the customers table? What is the primary key? Okay, dot customer ID equal to, what is the table with the foreign key? What is the table with the foreign key? Now, good. The table with the foreign key is the account table dot what? What is the foreign key? What is the foreign key in the account table? What is the foreign key in the account table? Good. Dot customer ID. Ladies and gentlemen, this is joins. Your join don't finish. Good. So now we now move to the last thing that SQL will actually read, which is the select. Okay, so whatever is here. So this is what you want to retrieve. Now, what did they ask us to retrieve? They asked us to retrieve customer first name and customer last name from the customers table. So the first name and the last name is found in the customers table. So we say customers dot what? First name, comma, customers, sorry, dot customers dot last name, comma. We need to get the account details, okay? That is coming from the account table. So we say account dot account type, comma, account dot balance. Ladies and gentlemen, we have our query completed. Do you understand? Do you understand this? And if I execute this, can you see that it has successfully extracted data from two tables, from the customer table and the account table? Now we are able to see the customer's first name, customer's last name, the account type that they created, and then the balance that they created. Let me know if you understand. Good. This is the use of a foreign key or a primary key and a foreign key in a table. That is it, ladies and gentlemen. Okay, so now I think we are actually going to move into the next thing that I want us to talk about. Okay, we're going to move into the next thing that I want us to talk about. Okay, and the next thing I want us to talk about is The next thing I want us to talk about is data types. Okay. Remember, okay, let me explain. Now, in a relational database, okay, in a relational database, each column in a table, each column in a table is assigned a specific data type. And it is this data type that defines the kind of data that can be stored inside of that column. Okay. I will take that again. Each column in a table is assigned a specific database, or sorry, a data type inside of a relational database. And it is this data type that defines the kind of data that can be stored inside of that particular column. Okay. Good. So for example, let's look at the columns inside of the customers table. Can you see that for the first name column, we have a data type called nvoucher. We have a last name column. The data type is nvoucher 50. The date of birth, we have date, data type, the address, and so on and so forth. Okay. So for example, inside of Excel, you can change your data type. See, this is an example of a data type. You could change it like this. Okay. So where you have your general format, you can format that particular column to be a number column. You can format it to be a currency, accounting, short dates, and so on and so forth. That is basically the same thing that goes on inside of SQL. Okay. So I think now the data types. Data types. Okay. Now in data types, we have different types of data types. Okay. So we have example popular ones are the integer, we have the float, we have the char, we have the varchar, and then we have the text, we have the dates data type, we have the time data type, we have the Boolean, sorry, we have Boolean, and then we have decimal data type. Okay. So these are the most common data types. Okay. These are the most common data type. Now, these data types, what they do is that they help to ensure data integrity and provide a way to enforce constraints on the type of information that can be stored in a particular column. Okay. Say, for example, if you use the integer data type for an employee's age column, best believe me that only whole numbers will be accepted for that particular column. Okay. And then when designing a database schema, it is very, very essential to choose the appropriate data types based on the nature of the data and the operations that will be performed on that particular database. Okay. So yeah, that is it. Honestly, the time is not enough. Oh. The time is not enough. The time they very, very small. Okay, because we've not gone half. We've not gone half. Okay, should I continue? Should I continue, or you guys want me to stop? Hey, Oga moderator, I will continue. I will continue.
No problem, boss. I think they also
Okay.
want you to continue, so just
All right.
go
All
on.
right.
Or
Because
let's just make it like maybe 10 minutes,
oh
so we don't make
shit.
the recording too
But
long.
wait,
So
oh, wait,
mm,
wait, wait. Mr. Moderator. We see we've not gone half of what I want to discuss. Oh. How we go use that?
so all right, let's just
I
go on
think
now. Since
they
you're
have to
saying we should
manage
continue.
even if like if it's like even if it's like maybe 1 hour, 1 hour 30 minutes or to like 1 hour 30 minutes and above. I think they need to like manage it that way. They need to watch the recording like that because you know this is like the foundation of SQL. I think this class is supposed to be like the first class because this is the foundation on which SQL is built on. So I think to understand anything moving forward, I think this is the part they need to understand the most. Sure you get. So that's why I'm trying to like break everything down. Good. All right. So I'll continue, guys. I'll continue. Please bear with me. I'm sorry. All right. So now we are going to look at SQL constraints. Okay. Good. So in English, you know what a constraint is? SQL constraints, they are used to specify rules for data in a table. Okay. And then the constraints, you can specify it when the table is created or after the table is created. Okay. And basically, constraints are used to limit the type of data that can go into a table. This ensures the accuracy and reliability of the data that is inside of the table. Now, there's something very important that you must understand. If there is any violation between the constraint and whatever data action it is representing, that action will be aborted. And in SQL, constraints can be column level or table level, and column level constraints apply to a column, and table level constraints will apply to the whole table. Okay. Now, basically, these are the constraints that we have. We have the not null constraint. Okay. We have the not null constraint. We have the unique constraint. We have the primary key. The primary key is also a constraint, and we also have the foreign key constraints, and then we have the check constraint. Okay, good. So now, mind you, okay, let me explain each and every one of them. Okay, so first of all, we are going to look at the primary key. Okay, you see, you need to understand primary key and foreign key because the principles of SQL is built on primary keys and foreign keys. Okay, you need to understand them very, very well. Okay, and honestly, right now, I think I'll go a little bit deeper into what primary keys and foreign key is. Okay, good. So let me explain. Okay, let me explain. I'm going to be explaining with my mouth. Okay, I think you need to watch the recording later on, but I'm going to show you practically what all of this is. Just sit tight with me. Now, like I said before, a primary key is a unique identifier for a record in a table. Okay, and a primary key, it must contain unique values because no two records in a table or the table can have the same primary key. The primary key is used to establish relationships between the tables inside of relational database. Mind you, I'll backtrack a little bit. This entire stuff we are doing is because we are studying relational databases, okay? We are studying relational databases. And look at the name. It says relational databases. And like I told you, tables are called relations, okay? Because it is called relational databases because this relationship exists between these tables that exist inside of relational databases. Mind you, data inside of relational databases is stored in tables. Okay, now these tables, they have relationships, and what brings about this relationship? It is through the primary key. The primary key is used to establish relationships between tables in a relational database, and it ensures that each record is uniquely identified, making it a very, very crucial component for data integrity. Three things you must understand. One, the primary key constraint uniquely identifies each record in a database table, and primary keys must contain unique values and cannot contain null values. And a table can only have one primary key, which may consist of single or multiple column. Okay, so that is that for the primary key. Good. So let's look at the foreign key. Okay, now, like I said before, the foreign key is a column or a set of columns in a table that refers to the primary key of another table. We saw it. Okay, it establishes a link between the two tables, allowing for the creation of relationship. Okay, so like I said before, the primary key in one table, typically corresponds to the foreign key that is inside of another table. Okay, now this relationship is very, very crucial for maintaining referential integrity, as it ensures that the values in the foreign key column matches the value in the primary key column. Aha. Today, not today. Okay. Ah. All right, let's look at the next thing, which is the not null constraint. Okay. Now, when we say what is a null value? What is a null value? Can anybody try? What is a null value? Null. Null value is an empty, or null is the absence of a value, okay? Absence. No, null is not zero. Null value is not zero. Zero is a value. Null is not equal to zero. Zero is not equal to null. Null is the absence of a value. And the not null constraint is used to ensure that a column in a relational database cannot have a null value. Like I said, a null value represents the absence of a value or an unknown value. And if you apply the not null constraint to a column, you are mandating that every record in that table must have a valid and non-null value for that particular, for that specific column. That is basically what is it, okay? So null value is absence of value. Null value is absence. Don't ever say null value is equal to zero. Please, please. And let me tell you something. You normally encounter missing values or empty cells. Please don't fill it with zero, because it is not zero. Because number one, you don't know why that place is null, because sometimes some null values are put there on purpose. Sometimes they are put there by mistake. Sometimes it is because of structural errors or maybe some formatting errors or something like that. So don't assume it is zero. It is the absence of value. Good. So yeah, I think I would take a break on that for the constraints. Okay, good. So I think I want us to look at something else. Okay, so I want us to look at the. I think I want us to look at something else. Okay, so let's look at. Okay, no problem. Now for this other part, for this other part, for the practical part of things, I think I'm going to be showing you how to create a database and how to design a database. That is the main thing I was asked to teach today, database design. Okay, but if I did not explain all of these things, you never understand how to do it or how to come about it. So that was the most important part of things. Okay, good. So now we are going to create a database. Okay, so I want you to sit very, very tight with me. Okay, now I am looking for a case scenario. All right, no problem. So now for this database that we are going to be creating, okay, I want you to assume the position of. Now normally, let me explain something. Okay, let me explain something. Normally, as a data analyst, if you are being if the employee you are the data analyst, or if you're working as a data analyst, I don't think there might be. I think it is very, very it is a very, very rare case scenario that you as a data analyst will be asked to create a database. But nevertheless, understanding how to create a database and how to create the tables, how to create a standard database is very, very important, because you as a data analyst, most of your job would be retrieving information from a data or from a table or from a database. You need to understand how it is built for you to properly analyze data inside of a database or to properly retrieve information accurately. That is why it is always very, very good for data analysts to understand how to design a database. Good. So for this scenario, for the database we are going to be designing, we are going to assume that we are working as data professionals or as data analysts for a hospital. Okay, so we're going to be assuming we are working for a hospital. Okay, so say for example, you joined a hospital and you find out that they don't have any database. Okay, so you find out that they don't have any database and you want to create one for them, or they ask that you create a particular database for them. Good. So that is what we are going to do now. We are going to create a database for a hospital. We're going to try to make it as standard as possible. Okay, so we're going to create the database and then we are going to normalize the database. Okay, and then we are going to create the relationships, the entities, and the attributes. Good. So inside of SQL Server, okay, inside of SQL Server, when you come here, let me close all of this. Just give me a sec. Let me close all of these. So when you open your databases, you would see databases you've created. Okay, I know most of you may have or may have not created one before, but I think creating a database is very, very easy. Okay, now that brings me to what I would want to discuss. Okay, now SQL as a language, SQL is divided into 4 subsets, okay, or 4 sub-languages. It is called subsets or sub-languages, okay? Good. Now, these are, we call them now majorly, I think majorly, and let me use majorly. Let me watch my words, sorry. Is divided majorly. Let me not conclude. Maybe I think uh, we are all limited in knowledge. But majorly, from what we know and from what we see around, it is divided into 4 major subsets or sub-languages, okay? We have the data definition language, okay? We have the data manipulation language. We have transaction control language. And then we have data control language. Good. These are the 4 major subset or sub-languages inside of SQL. Good. Now, you see, as a data analyst, only 2 of these languages or subsets is very, very important to you. You see these two? You see these first 2? That is the 2 major ones that are important to you. So in all your learning, just probably focus on this. Okay, so people that basically look at all of these transaction and data control are people that are doing database administrators or people that look into it very, very well. Now, as a data analyst, you might just need to know 1 or 2 things there, which is very important, but that is not your calling at all. You are far from that place. Okay, so people that might look into it are people that want to be database administrators or data engineers and all of that stuff. Okay, but you see, if you're a data analyst and a data scientist or the normal data stuff we do, this is your focus here: data definition and data manipulation. Okay, good. So we are going to look at data definition language, and it is all, we also call it DDL. Okay, so it is also it's also called DDL. Okay, now the DDL or data definition language. Okay, now the commands inside of data definition language are used to define. They are used to define the structure of database and database objects. Okay, example of database objects are things like you have your views, you have your indexes, you have your constraints, you have your tables. These are examples of database objects. Are you guys following? Are you lost? Are you guys following? All right, good. So, like I said before, data definition language commands, okay? Now, inside of data definition language, there are commands, okay? There are commands. These commands inside of data definition language, they are used to define the structure of database and database objects. And I listed examples of these database objects, okay? Good. And now an example of a command that is inside of data definition language. One is, we call it the create command. Someone is lost. Charity, where are you lost? Please indulge me. Please, moderator, you can unmute her mic so that she can speak. If she type, it's gonna take more time for us, please. Please just unmute their mic. If they raise their hands, please unmute their mic. Let me clear the air a little bit. I know it's a whole lot of information to take in at once. I've just been bombarding you guys with like information you're supposed to consume inside of 1 week. I'm just giving inside of one class. I understand. I'm sorry, but I just have to do it. Okay. Please,
Charity, please raise your hand so I can
please raise your hand so you
open.
can unmute your mic. Sorry. Okay, if Charity is not raising their hands, I think someone is raising their hand.
Yeah,
I think
Sylvester, you can go now.
Sylvester.
Sir, please come lost. You just say something. Now, under the example that you gave, that you give the constraint and
I can't hear you properly, sir. Okay, I think you might need to type that as well. Please.
Can you hear me now?
Yes. Thank you.
Okay, so under the example, like the view, the index, the constraint, and the table, you said they are example of database objects, right? If I'm right,
Yes.
I don't know. Okay,
Yes.
so you're about mentioning create again. Create is now under what? Is it also an example? Because you say it's an example of, is it an example of command or an example of database objects also?
Okay, it's an example of commands. Okay.
Okay. Thank you.
Yes, data definition language has commands. Okay, so look at examples of commands in DDL. We have the create command. Okay, we have the alter command, and then we have the drop command. These are the three major commands inside of data definition language. Okay, and these are the three major commands that makes up data definition language. Good. So we are going to look at each of these commands one after the other. Okay, very simple. Okay, good. So we have the create command, and the create command in SQL is used to create, okay, it is used to create database and database objects. Okay, it is used to create database and database objects. Okay, say for example, we want to create a database. Okay, so we are going to create a database here. Like I told you, the project we want to work on, the use case we want to work on now is we want to create a hospital for we want to create a database for a hospital. Okay, so we might give it a name, but I think we might just call it hospital DB. Okay, good. So now you see all of these things I've been doing since, all these things I've been writing here, and you see them in green color. All of these things in SQL, they are called comments. Okay, they are called comments. Okay, so this is me just writing a comment. And as a professional, always remember this. If you don't learn anything from Splendor, learn this from me today, that as a professional, the most important thing, or the most important thing you can do whenever you're writing your code, is to always add comments. Okay, always identify or always indicate your thought process. You understand? I may not have enough time to explain why you need to always put comments in your code, but please, and please, in Jesus' name, please always have comments in your code. Okay, good. So now I'm going to add a comment here. So I'm going to add a comment to say, create a database called hospital DB. Okay, I'm going to call it hospital database or hospital DB. Let me just call it hospital DB. Okay, good. So that is our code. Okay, that is our comment, and that is our intention. Okay, so like I told you, SQL, the syntax of SQL is English language syntax. Okay, it is literally the same thing. If you understand English language, you understand SQL. Okay, and SQL is English language. Okay, so we want to create a database. Now we are using the create command. This is the first command inside of SQL. So we say create database, and then we are going to specify the name of the database, which is called hospital DB, and then we end with a semicolon. Ladies and gentlemen, this code right here is the code to create a database called hospital DB. Do you understand? Good. So if now everything in SQL is a command. Now let me tell you something. Let me explain something to you guys. I need like I need like 1 month with you guys. I need to put SQL inside of your head. Like, I need to like break it down and like infuse it inside of your head. Okay. So let me explain something. Let me explain, because you need to understand SQL very well, the way it behaves, the way it behaves. Now, SQL as a language is non-procedural. SQL as a language, let me put it as a big comment here. SQL as a language, non-procedural. SQL as a language is declarative. Declarative. If you want to make a comment, oh, I'm coming. Just hold on. Just hold on. Let me explain what I'm explaining. Now, the next question you might want to ask me is, what do you mean by SQL is not procedural or non-procedural, that it is declarative? It means that in SQL, you don't need to tell SQL what to do. You don't need to tell it the procedure to follow. You just need to declare a command, and then SQL is going to run that command the same way you said the command. You don't need to tell it. SQL by itself knows what it needs to do. The engine knows what it needs to do. All you just need to do is to declare the command. This is a command. We are giving SQL a command to say, create a database, call it hospital DB. And in SQL, we execute commands. So if you click on execute, you're going to see a message that says commands completed successfully. Are you guys following? We've successfully created a database called hospital DB. Good. Now, To see your database, all you just need to do is to come to your databases here, right click on it, and then click on refresh. When you click on refresh, you would see that we now have a new database here called Hospital DB. Mind you, our database is empty. If you open tables, you see no tables. We have no data inside of it here. Nothing. It is empty. Good, we understand that. But the main thing is that we successfully created a database called Hospital DB. Good. Now, in SQL, if you want to write a comment, like I saw someone complaining, all you just need to do is to write, now we have two types of commenting style, okay? We have where you put double dash like this. If you put a double dash like this, you see it turns green, okay? This is a comment, okay? Now, this is the short writing style of a comment, okay? So this is the short style, okay? And this is my favorite style. Now, the other style is the long style, okay? Where you put a forward slash with an asterisk here. You see, you can write as much things as you want. Like, if you are done writing, you can come down here. You can come down here and then close your stuff, okay? You see, it has closed, okay? You no longer have a comment now. So if you want to write longer stuffs, use this method, okay? But if you want to write short stuff, I think I like using the short style. So that is how to do a comment inside of SQL. Good. And for SQL, there's something you must understand. There is writing patterns, okay? There are writing patterns inside of SQL. There are two major writing patterns inside of SQL. We call them the camel case and then the snake case. So this is camel case and then this is snake case. Good. You see, SQL does not like spaces. SQL does not entertain spaces, okay? And because it does not entertain space, is either you use the camel case where you join the two words together, but you separate them this way. So you see camel, and then you have case, and then where you have snake, and then where you have case, where these two words is separated by an underscore. Okay, so these are the two that SQL takes. So space, no. When you are defining things in SQL, no space. No space. Do you guys understand that? That is why I have my hospital DB like this. Do you understand that? All right. Now, there's a semicolon here. I guess I have to explain what a semicolon is and what it is doing there. By the way, you need to always tell SQL that I am at the end of my command, and that is what the semicolon do. Please always maintain the habit of writing your semicolon or putting your semicolon at the end of every command. Okay? At the end of every command, just put it there to tell SQL that this is at the end of my command. This is the end of this command. You understand? Good. So, yeah, someone is asking a question. No, I said the space is when you are defining something. You see this one? This one is a command instead of SQL. This one is a command instead of SQL. I mean, when you are defining it, now, mind you, this is create database. You are specifying the name of the database. So when you are specifying something, when you are creating something, when you are defining something, that is when you don't have space, but not in the this thing, okay? Now, and also something else you should understand is that SQL is not case sensitive. Okay, so you can write in capital letter, you can write in small letter, you can write anyhow you want to write it. It is not case sensitive. And also, SQL is not positionally sensitive. Okay, I mean, I can write this like this, I can have this like this, it is still going to work. I can have all of it inside of the same line, it is still going to work. So it is not positionally sensitive. Okay, understand that. Perfect. I think I have done enough background on that. These things, you guys should have covered all of these things, but I'm just trying to backtrack a little bit. So yeah, we've created a database. Now, mind you, this is one way of creating a database inside of SQL. Another way is you can come to your databases. You see these databases here? You right click on databases and then you click on new database. Okay, so this is if you don't want to use code. Okay, so you give your database a name and then you click on OK, then you've created a database successfully. Okay, good. So now for what we want to do, I think we've created a database called hospital DB. Okay, good. So now what do we do next? If you've created a database, the next thing is to create the tables that will hold data inside of that particular database. Okay, good. But now, mind you, always check here. Okay, when working with SQL Server or SQL, always check here. Always make sure that the database you want to work with is the database that is selected here. Now, you see what is selected here is master. Okay. Now, me to change it to this particular hospital DB so that anything I'm doing is going to be having effect inside of the hospital DB. All I just need to do is to say use hospital DB like this, and then I will execute the code, and then it says command successfully. Can you see it has automatically changed to hospital DB? Now to do it manually, you can just come here and you will see a list of your database. Just select hospital DB and it will take effect. Okay, good. So now the next thing is that we need to create tables. Okay, we now need to create tables and we now need to define the relationship. Now, creating a database is a very tricky something. Okay, good. So now we are going to create different tables. Okay, now inside of a database, now I think one of the first table we want to create should be something like the patient table. Okay, I think we need to have the patient's table. I think we need to have the doctor's table that will give us information on the doctors. Hello, can you guys see my screen? I think it's not from me. I think it's not from me. My stuff is very good. As a matter of fact, I'm using a very good network. So I think it's all good from my end. Please check your side, okay? Good. So now I think we need to create these different tables. Okay. So you see all those tables you work with, all those tables you work with. I think this is how it is created. So learn how to create it now. Good. So we will create the patient table. This patient table would hold information on on the patient. Okay. So it's gonna give us every information we have on the patient. Then the doctor's table is going to give us information on our doctors, you know. And then I think I would want to have another table. So we want to have another table called appointments. Okay, so this would give us all the information we need, or this is the table that's going to hold all the data on the different appointments that doctors have with patients and all of that stuff. Okay, so that is how we're going to do it. And I think maybe I want treatment. I want table called treatment. So this is a full database. So I would have treatment, I would have department. I think I would also have medical records. Okay, medical records. Okay, because it is very important to have the medical records of your patient. You need to have that data. Very important. It's not this thing it's not the way we do back here where we don't have medical records. Somebody will just come to you for treatment, you just jump and you start treating them. No, you need to have a record of that person's past illnesses, if there's any reoccurring ailments or some sort of stuff like that. Okay, so I think doctors need to be more informed. Okay, they need to check your record. They need to check if you have an existing sickness or something like that. Like I said, SQL is logical. You see how I am joining logic to a problem that we are solving. And mind you, I will tell you guys this for free. I'll tell you always, any day you are writing SQL codes and the SQL codes you are writing, they are not being used to solve business problems or problems for the world, then the purpose of why you learned SQL has been defeated. Understand that SQL is a means to an end. It is a means to solve problem. You're not just learning it because you want to learn how to code or some sort of stuff like that. You are learning it to solve problems. And anybody who is going to hire you as a data professional or as a data analyst, they are hiring you because they want you to help them solve problems. Is either you're helping them to increase their profit, you're helping them to reduce their losses, you're helping them to optimize their processes, or you're helping them to automate their processes. Anyone, be valuable. It is not enough to learn Excel. It is not enough to learn SQL. It is not enough to learn Power BI as tools. Learn them because you need them to solve business problem. Mind you, here we have a problem where we want to create a database for a hospital, okay? So we've outlined the tables that we want to create, okay? So we want to create 6 different tables. By the end of this course, you should be able to create a full standalone database for any business at all. Good. So now, another assignment, okay? Mind you, please submit this assignment. Don't play with me. Submit this assignment, okay? Submit this assignment. If you don't go, if it's either you find me on Twitter or you find me on LinkedIn or you find me on WhatsApp, please submit this assignment. Very, very important. The next assignment is I want you guys to read about normalization. Okay, so I want you to write not less than 300 words on normalization. Okay, the types of normal forms. Okay, so normalization and the types of normal forms with real world examples. Please submit my assignment. Thank you. Let's proceed, because if you read normalization, you come and thank me later. Very, very important. You come and thank me later. Okay, so now we've created, mind you, inside all of these things, we are still in the create command of data definition language. We are still in the create command. We are still trying to create things from scratch. Okay, so we are still trying to create things. We've created a database. One, we want to create a table. Good. So now, like I said, we need to create the patient table. Okay, we need to create the patient table. Now, mind you, all of these tables we are creating, they need to be related. Okay, so the relationship needs to go very, very well. Perfect. So now the first table we are going to create, to create a table, okay, the first table we are going to create, so we're going to say, we're going to give a comment to say, create table and call it patient. Okay, and call it patient. This is going to be our patient table. So you as a patient, you have a table, you have a record where the hospital has your record and everything. Okay, good. So now I'm going to write a code. So like I said, SQL is English language. You see, now we want to create a table. We are basically telling SQL to say create table and call it patient. Okay, now I am going to open up a bracket. You open up a bracket after you write patient. Why? Because we said before that a table is made up of rows and columns. Okay, so we need to define the columns. It is the columns that hold the attributes of the data inside of the table. Okay, so we need to have our columns. Okay, good. So can somebody advise me, what do you think is the first column we should have in a table that is called patient? Based on what we've spoken here, based on what we've done here so far, what do you think is the first column? Thank you so much. Patient ID. Anytime you are creating a table, the first thing that should always come to your mind is your primary key. Very important, your primary key. So you need to create a patient ID, okay? So we call it patient ID. What is the data type? Because we want it to be whole number, the data type is going to be integer. okay? And then we are going to specify to SQL that we want this particular column to be our primary key. And ladies and gentlemen, this is our first column. Patient ID, integer, primary key, okay? Good. So I want to have another column. This column is going to be called first name, okay? So I'm going to give it a data type of varchar, okay? Now, varchar basically means varying character, okay? Now, mind you, I am basically saying this person's name, this first name column, it cannot be more than 50 character. That is what this 50 here basically means. So if you like, may your name be Osas or Bumegum or Sanobua, anything. If you pass 50 character, SQL will automatically cut your name short. It will cut your name short. So I'm basically saying for this first column, for this first name column, every patient, their name must not be more than 50 characters. Do you understand? Then I would set a constraint. This is how to set a constraint. So we say not null. Now, let me ask you guys a question. Have you ever tried registering for something online before? And you mistakenly, maybe because you are rushing to like fill out the form, maybe you did not now put an important, you did not fill an important column, and then you are trying to submit, and then you see that the website quickly throws up an error, and then it tells you that there's a column you've not filled. That is what this not null, that is what it is doing here. That means you cannot leave this first name empty. Everybody, every patient must put in their first name. It cannot be null, not null. Are you guys following? Are we understanding? All right, good. So I think I would also have another column called last name. I would also set that to the varchar 50, okay? Varchar 50, okay, comma. I will set that to varchar 50, comma. Good. I also want another column. I think I want to be able to know the day that that particular patient was born. Very, very important. Date of birth is very, very important in medication. I know in your mind, you might be asking yourself, how would I be able to know all of these medical things? Mind you, say for example, I tell my students that research is the most important weapon of any data analyst. Because as a data analyst, every single day of your life, you'll be solving problems. You are required to solve problems. You'll be solving one or two problems or the other. And these problems on the normal day, nothing concern you. You see, for example, today we are talking about bank database and all of that stuff. You see me microbiology in school, nothing concern me with anything that concern bank. You see, the only thing that brought us together is just because I did data analysis, and that is it. So you need to make research. Before you start solving a problem, you need to make research. Very important, okay? And in any analysis you do, or in any analysis you work on, one thing I always tell my students, make sure that in any analysis you do, make sure you are the most knowledgeable person in that particular topic. May nobody sabi that topic pass you. The worst thing you will do is to do an analysis and you want to go and present it in a room and you do not thoroughly, grandly do the analysis or know about everything that pertains to the analysis. Because if they ask you a question and you're not able to answer, your credibility will run down to zero. And if you want anything good for yourself, avoid, as a data professional, the day that someone would ask you a question and you realize that you don't know the question. Nobody will ever trust your analysis. Again, very important. So research. I will not say it again. Good. So now, date of birth, the data type is date, okay? The data type is date. Then I want to be able to know the gender, okay? The gender of this particular patient, okay? So I would set it to char 1. Now, let me digress a little bit. You see why I talk, see why I said I need like 1 month with you guys? Because now, a very, very important interview question that comes up anytime you hear things that has to do with SQL is somebody will ask you, what is the difference between the char data type and the varchar? Now, let me explain something. Let me explain something to you. Now, the char basically means character, yeah? And then the varchar basically means varying character, okay? Now, the difference between the char and the varchar is that the char is a fixed length character string, okay? This is a fixed length. More English don't finish on my mouth today. Fixed length character string, okay? Whereas this other one is a variable length character string. So now you see the first one is fixed and the second one is varying. Okay. Now let me tell you why. Let me tell you the difference. When we say this one is fixed, the char is fixed and the varchar is not fixed. Now let me show you something. in this table that we are creating now, do you know that if we say we set a data type to the first name column to be varchar 50, what this means is that your name, you can write your name. If your name is between 0 to 50 characters, the system is going to accept it. But your name cannot be more than 50 characters. So the limit is 50, but your name can be I, your name can be AB, your name can be 3 characters, your name can be 4 characters, 5 characters, 6 characters from 0, but making sure it is between 0 to 50. If your name is more than 50 characters, you no go agree, it will not accept. But the char is a fixed length character string, meaning that if you put 1, it must be 1. If you put 2, it must be 2. You cannot go below 1. You cannot go below 2. You cannot go more than 1. You cannot go more than 2. Do you guys understand? Do you understand? All right. Perfecto. So for this char, I just want to have 1 character. Okay. For the person's gender, I just want to have 1 character, either M or F. If the person puts M as their gender, it means male. If the person puts F as for their gender, it means female. Gaskia, finish. Good. So now I also want to have the person's address. Okay. The person address, I think I'll make this varchar 255 characters. Okay. And then I want to have the person's phone number. Okay. So I would have phone number. I would set it to the varchar 20. So it cannot be more than 20 characters. Okay. I've not seen any phone number that is more than 20 characters. Now, somebody will ask me, but phone number is numbers. So we should have used integer instead of varchar that we use for text. Now, the answer to that question is, do you perform calculations on phone numbers? Do you perform calculations on phone numbers? If your answer is no, then you are correct. Apish, finish. Problem solved. Okay. Then we need to have the email column. Okay. So the person's email column. Okay. So email. Okay. I will set that to varchar. Set a constraint on this for this person's email to be unique, but let me just keep that. So that is a constraint. So I will come here and then I will close this bracket that was opened here, and then I will put my semicolon. Ladies and gentlemen, I have created the first table. I have successfully written the code to create the first table that is called the patient's table. And in plain English, we can read this code as we've told SQL to create a table called patient. And inside of this patient table, we want to have the patient ID column, which we've set the data type to the integer, meaning that this column can only hold whole numbers. And we set that column to be our primary key. We also created the first name column. We set the data type to be varchar 50, meaning that it cannot have more than 50 characters. We set the constraint to be not null, okay, meaning that it cannot have null values. The last name column set to varchar 50. The date of birth we set to date. Gender we set to char1. The address we set it to varchar 255. The phone number we set it to varchar 20. And the email we set it to varchar 100. Now, someone is asking, why is the address in blue? The address is in blue is because SQL already has an inbuilt command or function that is called address. So if you notice, all of these commands that belongs to SQL, you see all of them are in blue. The ones I am writing are in black. So there's already something that SQL will have inside of a system that is called address. So me, I still came and I use address. So that is why it is showing blue. But because I am defining it, it will take what I am doing. Sure you get. So I will just highlight all of this and click on execute. And as you can see, it says commands completed successfully. And we need to verify the table, okay? So I will just say select star, okay? Select star from, what is the name of our table? Patient. Can you see we have the table here? And if I highlight this and execute, can you see we have the skeleton? Mind you, data definition language, again, like I said before, is used to define the structure of database objects. And one of the command inside of data definition language is the create command. Can you see we've been able to find the structure of what this table should look like? Now, there is no data inside. We just have our column. So if you come to databases, come to hospital DB and open your tables. Sorry, let me refresh this. Okay, so we refresh. Let's click to refresh. Can you see we have a table here called patients? Okay, if you open the columns, you see the columns here. You see we have all of these. Can you see this is my primary key? Can you see the key? It is showing. Can you see? Good. Now someone is asking, sometimes ID might have a text and number together. What should we set the data type to? Set it to varchar, please. Okay. Set it to varchar. Okay. All right. Let's continue. Okay. So we need to create the doctor's table, and then we need to create appointments table, the treatments table, departments table, and medical records. So this is our first table. That is why it is a little bit stressful. Okay. Okay. So just sit tight with me, guys. I know I've taken your time. I'm really, really sorry. I just need to satisfy my conscience that I taught you what I needed to teach you. Okay, good. So then we need to create the doctor's table. Okay. Now this time around, I think I will be a little bit faster. Okay. So we say create table, and we call this table doctors. Okay. So we open up a bracket. Okay. So, okay, before the doctor's table, I think I would need to create the department table. Okay. So give me a second. So I think I would need to create department table. So I would say create table and call it departments. Okay. So I'll open up a bracket. So the first thing I would have here, department ID, that would be an integer, and then that would be a primary key, comma, and then I think I would have my department name. Okay, so that would be a voucher 100. Let me just leave it to voucher 100. Okay, and then I think this is the end of this table. I think I am satisfied with that particular table. Okay, so for now, so I will highlight on this and then I will execute. You see command completed successfully. Let me refresh my tables to see if my department table is here. Okay, so I will refresh that. As you can see, I have my department tables. These are the columns. You see department ID and department name. Good. So now I can create my doctor's table. Okay, good. So I would say create table and call it doctors. Okay, now inside of the doctors table, I think I would have my primary key, which is the doctor's ID, which is going to be an integer column, and then it's going to be my primary key. Okay, I think I would have first name. Let me copy all of this. Okay, first name, date of birth, or first name and last name. Let me copy all of that. I think these are the things I don't want to be writing them. Okay, so comma, I think I want to know the doctor's specialty. Okay, so I'll have specialty, and the specialty would be um, let me leave it at voucher 100. Okay, leave it at voucher 100, and then I think I'm gonna have an email column. Okay, I'm gonna have an email column and then a phone number column for the doctors. Okay, so the doctor's phone number so that we can reach them in case of an emergency. Okay, or in that case, good. I think then I want to create a link between the doctor's table to the department. You understand? So every doctor should have a department. Okay, good. So I would say I will create a foreign key. Okay, here I will create a foreign key, and that foreign key I will call it department ID. Mind you, I have created the department table and I have department ID as a foreign key here. So I want to create it as a foreign key to connect the department table to the doctor's table. So this department ID is going to be an integer column, and I will say that this column references the department table where on the department ID. And ladies and gentlemen, this is how to create a foreign key. There's a mistake here. Where am I making a mistake? References department. What am I not writing very well? Okay, hold on first. Let me highlight and execute. Let me see. Okay, it's working. It's working. It's working. It worked. It worked. I think maybe because I've not executed that. But let me refresh and see my table. And let me see my doctor's table. Let me see the columns. Okay, yes, it worked. It worked. You see, I have a foreign key. You see, this is a primary key, and this is a foreign key. See the difference, how it looks, okay? Good. So someone asked if it is compulsory to use capital letter when we write the create table. Now, there is what is called the legibility and the readability of your code. And as a professional, you should maintain all of these things, okay? So as a general rule, not that it is compulsory. Mind you, I said SQL is not case sensitive. So if you write in small letter, if you write in big capital letter, it doesn't really matter. But you as a professional, if you look at this code, is it not readable to you? Can't you see, don't you see that the commands, I put them in capital letters, and the things I am specifying, I specify them in proper cases. Try to differentiate the command so that your code is readable and it is legible. So you get, that is the only reason why we are doing that. Okay, good. So we've been able to create the patient's table, the doctor's table, and the department table. Okay. So let me see. The next table I want to create is the appointment table. Okay. So I'm going to create a table called appointment. Okay. So I'm going to say create table and call it appointment. Okay. Good. So I would have the appointment ID. That would be an integer. That would be my primary key. And I think I would have the appointment date. Okay. That would be a date data type. Okay. I think I would also have the appointment time. Okay. I will give it a time data type. Okay. Good. Then now I'm going to link this appointment to the patient table and the doctor's table, because these are the two people that need to know appointment. So the patient needs to know their appointment and the doctors need to know their appointment. So I'm going to link the appointment table. So I'm going to create a foreign key that will link this appointment table to the patient table and the doctor's table. Okay, good. So I'm going to create a column here called patient ID. We'll make it an integer and say that it references the patient's table where on the patient's ID, on the patient ID column. Okay, comma. Then to the doctor's table, I would create a doctor ID. Okay, doctor ID, make it an integer and say that it references the doctors on the doctor ID column. Okay, so I'll come here. I think this is the end of this code. Okay, so we have all of this, and I would highlight and execute. Perfect. Okay, so I think I have two more tables to create, and then we see how good we've come. Okay, good. I have the treatment table. So create table and call it treatment. And inside of the treatment table, we want to have the treatment ID. That would be an integer, and that would be the primary key. Good. And I would have treatment description. Okay, treatment description. That would be a text data type. And then I want to have treatment date. Okay, that would be a date data type. Okay, and then I would connect this table to the appointment table. Okay, so I will create an appointment ID. make it an integer and say that it references appointment where on the appointment ID. Okay, I think that is the end for this table as well. Okay, execute. Oh, wow. I don't mess up. I made a mistake. Made a mistake in this. Ah, shit. Oh, okay. I've seen the mistake. I would correct that later. I'll correct that later. Okay. Let's just be going. I made a little bit mistake with the column name. That is why he gave an error. So it was not now matching. So, but yeah, we've gone past that. So we have medical records. Okay. So we create table and call it medical records. Okay. And inside of the medical records, yes, the description can be varchar, but sometimes your description can be long. So, and it's varchar can only hold a maximum of 255 characters. Okay, so you cannot go more than 255 characters. So that means if your description for the treatment goes more than 55 characters, that means it will truncate, and you don't want that. So that is why we use text. Text, you can write, just the write they go. Just the write they go. Text data type is the data type that is used for things like, you see, all those where you have, say, for example, if you buy things from Amazon, that those review boxes, it is text data type that is set behind there. You understand? So where you could write a long text, a long review, all of those stuff. That is data type that is set there. Good. So we have the medical records. Okay. So I want to have a column called the record ID. That would be the integer, and then that would be my primary key. Okay, and then I would have the record date. Okay, that would be a date data type, and then I would have record details. Okay, that would be text as well. Then I would link this records table to the doctor's table. Okay, and the patient's table. So they should be able to, doctor should be able to see their medical records, patients should be able to see their medical records as well. Okay, so let me go and copy this one I did before. Let me copy this one I did before. I don't tire to the type. Okay, so let me copy it and then paste it here. Okay, so I think that is it. I think that is all. Execute that. Okay, it says commands completed successfully. So ladies and gentlemen, we have successfully created the 6 different tables that we want to have inside of our hospital database. Okay, so you see we have a database here called hospital DB, and you see the tables inside. We have the appointment that is talking about the appointment. We have the department that is talking about the department. We have the doctors that is talking about the doctors. We have the medical records, the patient, the treatment, and all of that stuff. Okay, good. So now, in a case where we want to see this visually, in a case where we want to see this visually, there's what is called ER diagrams. It is called entity relationship diagrams. Okay, entity relationship diagrams. Okay, so to get the entity relationship diagrams for this particular database we've created, we want to see the relationship, how data is flowing. I don't know if you guys did database. You did data modeling. You did do data modeling. Did you people do data modeling? Okay, good. If you did data modeling, you should know what relationship is all about. What did they tell you the types of relationships, like one-to-one relationship, one-to-many relationship, and all of that? Did they show you that? Okay, good. That is very, very good. So you see that everything is related. Everything is related. Everything is related. Good. So let me open database diagrams. Okay. So if I right click on database diagram, you would see to create a new database diagram. So if I click on this to create new database diagram and click on yes. Okay. So it is going to ask me to add tables, okay? So I'm just going to add all of the 6 tables, okay? So I'm just going to click on add. I'm going to click on add, and then I'm going to click on add, and then I'm going to click on add. I'm going to click on add. I'm just going to add everything, just add everything, okay? Make sure everything is added, and then we close. Now, can you see that the system has automatically identified a relationship for me between my tables, okay? But let me just arrange it very, very well, okay? Let me arrange it very well. Let me drag this one to this place. Let me drag it like this, okay? Let me drag this one up here. Sorry. Is SQL not beautiful? So let me push this one to this part. Let me push it like this. Okay. Let me push it so that I'll have space. Good, 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 good. So this is the relationship. Can you see all our tables are connected? Now, ladies and gentlemen, this is a relational database. This is a relational database, okay? Now, let me ask a question. Let me ask a question. Now, can you guys see that? Can you guys see that the patient table and the appointment table are connected? Can you see that the patient table and the appointment table is connected? Okay. Now, if you see these two, if you see this now, you know we have one-to-one relationship and we have one-to-many relationship, and then I think many-to-many relationship and all of that stuff. Good. So you see, anytime it is showing you this to this sign, anytime it is showing you this stuff at the edge, it means that the connection from this patient table to this appointment table, this relationship is one to many. The relationship between the patient table and the appointment table is one to many. Do you know why? Because one patient can have multiple appointments. Oh, SQL is too sweet. SQL is too sweet. Now, can you see that appointment table has one-to-many relationship to the treatment table? Do you know what it means? It means that inside of one appointment, you can have many treatments. This is the logic. You know how though it is not hard. Now you know just one learner. I swear to God. Now you know just one learner. If you don't understand them by code, you go understand them by entity relationship diagram. If you don't understand by code, you go understand by pictorial diagram. Good. Can you see that from the appointment table to the doctor's table or from the doctor's table to the appointment, it is one to many relationship, meaning that one doctor here can have many appointments. And can you see all of the keys? You see the ones with keys on them, these are the primary keys. You understand? And that is where the relationship is happening, okay? That is where the relationship is happening. Can you see that the patient table has the primary key of patient ID, and it is able to connect to the appointment table because there is a foreign key called patient ID inside of the appointment table. Okay, so you see, it is connected. Appointment table is connected to the treatment table. How? Because inside of the treatment table, there is a column called appointment ID. So it is linking, the relationship is flowing. So data can easily flow inside of this system. And that is why we have what we call relational databases, because tables in relational databases have relationships, and this relationship that exists between the different tables are brought about by primary keys and foreign keys. Ew, ew, clap for me now. Oh, Jesus. Ah. Hey, do you understand or you don't understand? SQL is sweet. It's people that is thinking is hard. It's not hard though. It's very, very straightforward. Okay. All right. Now, um, uh, okay. Now, I think I will just have to stop at this point in time. Okay. But before we stop, I have few things I want to show you guys as well. Okay. I have few things I want to show you guys. Okay. So mind you, we just saw only the create database. Okay. The create databases inside of the data definition language. Okay. Now, there are also two more commands that we were supposed to look at. Okay. Which are, we had the alter command and the drop command. So we will not be able to cover it inside of this class. Okay, that's very, very sure. It's very, very evident. Okay, that will not be able to cover it. So I want you guys to look at the alter command and the drop command, and then I want you to also look at data manipulation language, which is the second language I talked to you guys about. Now, data manipulation language, it has commands, okay? And the data manipulation language commands, they are used to manipulate or modify already existing tables. Okay? Already, okay. Modify already existing data inside of a table. Yeah, inside of a table. Okay? And then it has three major commands as well. We have the insert into, okay, which is the one that is used to insert data into structureless tables like this that we created, okay? And we also have the update command, and then we have the delete command, okay? But let me just pick one here, insert into, okay? So let me show you how to insert data into a database. I think I created few data just at the background here. I just have them here that I want to insert. I will just show you. Now, inserting data into a table is very, very easy, okay? So you just say insert into, okay? You just say insert into, then you specify the name of the table that you want to insert your data into, which in this case, as you can see, is the department table. Then you specify the columns you want to insert data, then the values, okay? So you put in the values, okay? So you start to put in the values. So as you can see, into department ID 1, department name cardiology, department ID 2, the department name is neurology, and so on and so forth. So if I highlight and execute this, can you see it says 4 rows has been affected? So if I say select everything from the department table, and if I execute it, now, ladies and gentlemen, you can see that our department table now have 4 records inserted. You can see we have department ID number 1, the department name is cardiology, and so on and so forth. Okay. let me see if I can quickly insert the other records. I think I had some other records here. So let me see if I can insert that. Just insert it quickly. Okay. I've done for the doctor's table. Let me do for the patient's table. Let me insert for the appointment table. Okay. I, okay. Uh, I think I made a mistake before, so that is why with the table name, please be careful. I did not show you, I did not have time to show you how to alter. I would have shown you how to correct this mistake, where I had a little bit of error in the column name. So I missed one letter. So instead of appointment, I say appointment, something like that. So it was not the so, but you can change it. So as you can see, we've inserted data into all of these records, and this right here is a hospital database, okay, with an entity relationship diagram showing the flow of data and how data is moving and the relationship that exists between these different tables. Do you understand? Do you have any question? Okay. All right. Please, I know most of you would have questions, okay? So I know most of you would have lots of questions. So I think you can send me a message. This is my Twitter. That's my Twitter handle, and then my name is AGK Uchenna Splendor on LinkedIn. So you can just just quickly ask me, or you could get my number, just chat me up on WhatsApp, you ask me, clarify, and all of that stuff. Okay, so please, um I think this is where I'd stop. Okay, moderator, I'm sorry, I'm really really sorry. I think I must apologize for taking more time than I was allotted. I'm really really sorry. Just that the time you guys give will not be enough for me to like cover what I wanted to do. I'm sorry. Okay.
There's absolutely no problem. It was what every single second you spent. Like, I enjoyed the class. My head is swelling. I believe everybody who followed this class is feeling wow. See, the hearts are popping all over. So thank you so much, Mr. Splendor. It was nice having you. Please keep pouring out the arts, the handshake, the anything you people can send. I would have given you Michael, but there's no time. And then you guys are much. So let's keep pouring it out. Once again, thank you so much. It was great having you on the call. So any message, anything you guys need to clarify, please. You have his Twitter handle, you have his LinkedIn name. Reach out to him, send it in a group chat as much as we can. We'll find answers to them. So thank you everyone for staying this long. Thank you so much. I enjoyed the class and I'm sure you all did too. So that's where we draw the curtain on SQL. There's so much more to learn. So like
Hey,
you say, the time is
plenty,
not enough.
plenty,
So
plenty.
there's so much. There's subqueries, there's cities, there's it's Okpo, it's plenty. So you guys need to you already have the foundation and then just match on with it and then I'm sure we'll all do great. So thank you once again for staying right up to the end of the class. Mr. Splendor, thank you so much again. So
All right.
people say goodbye to I'll be saying bye bye to Oga Splendor. So we'll release him with much appreciation.
Okay. I have another
All
class
right.
scheduled by 8, so I'm rushing.
All right. Thank you so much.
All
All
right.
right now
Bye,
people.
bye guys.
All right. So thank you everyone for joining the class. I told you it was going to be hot and I'm sure you guys enjoyed it. So thank you so much. Do enjoy the rest of your evening and bye for now.